Hi, my name is Dr. Maya Tavan. I'm a postdoc research fellow at the Sustainable Nutrition Initiative.
Welcome to the iOTA model, an interactive dietary optimization tool built by the Sustainable Nutrition Initiative to explore nutrient-adequate diets. In this tutorial, we are going to run an optimization scenario and explore the key features and functionality of the iOTA app. Once you log into the app, you will see a Welcome tab, which contains useful background information about iOTA and what it's aiming to achieve. At the bottom of this page, there is the Proceed to the Model button that will take you to the main interface of iOTA. iOTA is country, age group, and sex specific. For that reason, users should first provide these details so that the baseline diet and a set of nutrient requirements can be determined accordingly. The baseline diet is derived from the National Nutrition Survey data for adult male and female consumers separately. Then you should choose what the model should minimize. This can either be changed from the baseline, which keeps the optimized diet as close to the current dietary patterns as possible, or you can ask the model to minimize the dietary greenhouse gas emissions or price. In any case, iOTA will always generate nutrient-adequate diets. In the additional settings, you can set a cap for the emissions and the price of the optimized diet relative to the baseline diet of the population you selected. These two are set to 150% by default. You can also exclude any food groups that you wish not to appear in the optimized diet. Next field allows you to adjust the physical activity level for a more accurate estimation of dietary needs. This is 1.4 by default, which reflects a sedentary work pattern with minimal physical activities. You can choose lower and higher PALs too. Lastly, proteins and amino acids are adjusted for bioavailability by default. User can untick this option to simulate equal bioavailability for all foods. Once you've set your preferences, you can click on the Run Optimization button to initiate the process. In a few seconds, the app will calculate an optimized diet based on the user's inputs. The results are presented in 7 tabs. We'll go through these tabs one by one, starting from the Overview tab, which is now in front of us. In this tab, a figure visualizes major food subgroups in the optimized diet on a mass basis. You can view the specific values by hovering over the figure. Highlights of the optimization outcome are also shown at the bottom of this page. The Food Group tab and the ones that follow all present the optimized diet side by side with the baseline diet to allow easy comparison. The output charts under the Food Groups tab show the weekly intake of different food groups in both baseline and optimized diets. You can view these results at a broad food group level shown as group or a more detailed level shown as subgroup. You can also use the toolbar at the right-hand side of this figure to explore the data in more details or to save the figure. The output charts under the Emissions tab show the greenhouse gas emissions associated with the optimized and baseline diets. Each food group is colored differently to make it easier to visualize their contribution to the overall dietary emissions. Similar to the Emissions tab, you can view how much every food group is contributing to the overall price of the weekly diets. The Nutrition tab is where you can assess the nutrient adequacy of your diet. You can view nutrient groups or nutrient breakdowns. Under the Nutrient Group section, you can view the nutrient content of the optimized diet alongside with the baseline intakes. Nutrients are categorized into 5 groups: macronutrients, vitamins, minerals, amino acids, and fatty acids. In the Nutrient Breakdown section, you can view the detailed contribution of different food groups to the supply of each nutrient. In the Tabulated Results tab, you can view the foods included in baseline and optimized diets at 3 levels: group, subgroup, and item. This table can be sorted alphabetically or numerically by clicking on the column headings. You can also use the search field at the top right-hand side of the table to search for names within the table. If you wish to examine the data underlying this model outputs, you can download this as a CSV file by clicking the Export Results button. References we have used to build iOTA are listed under the Data Sources tab. We hope you enjoy exploring nutrient-adequate diets using the iOTA model.
If you have any questions, please reach out.